Hi, and welcome to our discussion on synoptic scale features. In this video, we're going to talk about the different types of atmospheres. And atmospheres can be broken down into two very general types. That's either barotropic or baroclinic. So let's take a look at barotropic atmospheres first. Barotropic atmosphere is one where density only depends upon pressure. That means that pressure surfaces are also surfaces of constant density. And what this means is there's no temperature gradient on a constant pressure chart. And if there's no temperature gradient, there's no thermal wind. And that means that there is no geostrophic wind increase. Geostrophic wind is independent with height. So basically what this says is that constant pressure surfaces are also constant temperature surfaces, no temperature gradients. So if we take a look at a cross-section of the atmosphere, going from the north to the south, going up through the atmosphere, the solid black lines indicate your pressure charts, 200, 300, 500 millibar charts. This is looking from the side, and you notice that temperature lines, or isotherms, the red dashed lines, are parallel to the pressure lines in the atmosphere going up. And of course, as you go up, temperature decreases. That means that one of these black lines, one of these constant pressure charts, also is a constant temperature chart. And this is what it would look like if you're looking down on, for example, a 700 millibar chart. And I know this looks kind of strange, where you have no isotherms, but this is what a barotropic atmosphere is. For example, 700 millibars, this chart, everywhere on this chart the temperature is -7 degrees Celsius, as the red number says down in the bottom left-hand corner. So of course, if there's no temperature gradient, that means that there's no temperature advection. And if there's no temperature advection, or no temperature gradient, means also that there's no thermal wind, nor is there jet streaks. And of course, weather systems really don't develop, so there's no frontogenesis and no cyclogenesis. Now, why do we even consider barotropic atmospheres? Well, when they were first coming up with numerical models to simulate the atmosphere is very complex, so you had to make assumptions. You had to make very simple assumptions. One was there's no temperature gradient. So, you know, this is kind of a thought experiment. It's theoretical. What if there was no temperature gradient in the atmosphere? Of course, we know this doesn't really happen in our atmosphere, but it made it much easier for mathematicians and atmospheric scientists to develop the first computer models. First computer models back in the 1950s were barotropic models. So basically what happens in a barotropic atmosphere is weather systems just kind of propagate along. They don't develop, they just kind of advect along, and that's it. Now, in a baroclinic atmosphere is one where constant pressure surfaces intersect constant temperature surfaces. So if we're looking once again at a cross-section of the atmosphere from north to south, you know that to the north it's much colder. You can see these temperature lines, isotherms, intersecting or hitting these pressure lines. And these pressure lines are pressure surfaces in the atmosphere. Now, there are a couple of different types of baroclinic atmospheres, actually. There's one type that's called an equivalent barotropic. I know that sounds kind of strange. And then there's another one which is baroclinic or purely baroclinic. And we're going to look at the equivalent barotropic atmosphere in more detail in future videos. Okay, so now an equivalent barotropic atmosphere is a type of baroclinic atmosphere. So you do have lines of temperature on a constant pressure chart. Isotherms, in this case though, are parallel to height contours. They don't intersect on a constant pressure chart. And I'll show you what we mean here in the next picture. This is a weather map, 700 millibars, You've got the black lines which represent contours. And notice on this chart, you do have a temperature gradient now. In the barotropic atmosphere, purely barotropic, there are no temperature lines. Now there are temperature lines in an equivalent barotropic atmosphere. But notice that the temperature lines are parallel to the contours, which means that there is no temperature advection. So in an equivalent barotropic atmosphere, it's a type of baroclinic atmosphere, you have a temperature gradient, but there's no temperature advection. And you do have a thermal wind. If there's a temperature gradient, that means that the wind increases with height, but it doesn't mean that you have jet streaks. You'll have a jet stream. In other words, the winds will be moving along in the upper atmosphere, but they'll all be moving along at the same speed up there. They'll be stronger, but they'll all be about the same speed. You won't have any jet streaks. So that's the difference between barotropic and baroclinic atmospheres. And we're going to look at equivalent barotropic atmospheres because they happen quite frequently in our atmosphere.